Hey guys, welcome back. This is the part 2 of the word break problem. The problem statement here is given a string S and list of words. Check if the string can be segmented into one or more words in the given list. In the previous session, we have already solved this using DFS, right? So in this session, we are going to learn how to optimize it further, okay? We will optimize it further by using memoization, and also we will solve the same problem using DP and BFS, and this is the solution that we last time came up with. So let's talk a little bit about where are we eating the time. Okay, if we see this DFS solution clearly, the main problem with this particular solution is using this substring method. Of course, we have to use substring method here, okay, but we are using the substring method 2 times here. If you see this, we are using 2 times. By modifying this problem a little bit, we can actually get rid of this substring. The at least one substring method we can get rid of. If you have not seen part 1, please go ahead and watch first part of this particular problem. DFS problems looks very simple. The only difficulty with the DFS problem is actually coming up with the base case. I would highly encourage you to watch the first part before watching this second part, okay, so that you know where am I coming from. So here what we are doing, we are actually the second substring, we are getting the right part of the string, and we are passing that right part into our DFS method, right? Passing by copying new strings, it's taking a little bit of more time. So what we can do, we can actually instead of passing the string, we can actually pass the index, okay? Pass the index until which we have processed. So instead of passing this right string, what I can do, I can actually pass the string S, okay, and I can pass a index saying that, okay, this is my right part of the string. So you should start your recursion, you should start the DFS method, from this index, right? So this is what we are going to do. Yeah, undo this, and I will just write this method again, okay? So I'll call this method can segment DFS2, okay? And as I said, I will get rid of this second substring, okay? I will pass the string S, and I will pass from which we'll be starting our next DFS call. So I'll be passing the I index, okay? Now to do this, I have to update my method prototype, right? So I'll pass int I, or I'll call it start, okay? What I can do right now, instead of starting this for loop from 1 always, I can start the for loop from start plus 1, okay? And this should be start. Fine. What else? Okay. And of course, we have to call our method by passing DFS, okay, by calling DFS2, we'll pass the index starting from 0, okay? So I'll call DFS2 here, okay? And now look at this part of the code, okay? This is the widgeted set we are using, right? So widgeted contains S, we cannot write S here. So our goal was to check the right part always, right? So here S I we are passing, right? And that I is actually passed as a start variable, right? I can say string, okay, I can say right part, or maybe I will say substring again, okay, or maybe temp, okay, temp S dot substring and start. This is actually containing the string starting from the start index, okay? Now we'll just check if this temp string is in the widgeted set. If it is, then we'll return false, and we'll add this temp, okay, instead of S. We can actually get rid of this substring also. Okay, I'll let you know. Okay, that is next step. This is fine, we have worked on this part. Now let's revisit the base case. Okay, in the base case we have written s is empty. Here in the base case, what we are doing, we are actually checking if the right part is empty. So what we can do, instead of checking if s is empty, we can simply write if start equal to s dot length. So if the start index reach the length of the string, that means right part is empty. So length. Okay, so this is it. So here I have copied the same code, you can see that. Okay, and instead of this left substring, what I have done here, I have just removed that left and I just directly use this substring method. Okay, that's the only difference. It's same, there is no difference at all actually in terms of code. Fine, and we call can segment DFS 2. Okay, fine, let's test this. Okay, this is accepted, and now let's submit this. Fine, you see this, last time it was 7 millisecond, now after this optimization it is 5 millisecond and faster than 77% around, which is a lot better, right? Let's do some more optimization. Okay, let's learn how will we use memoization here. Okay, in this particular problem, even though we are calling it is visited, it is in fact almost using the memoization technique. In this particular problem, we might be processing the same string again and again. Okay, and what if the string is already processed? Okay, what if the string is already processed and we have returned true already for them? Then we don't have to come to this for loop, right? For all those overlapping sub problems, what we can do, we can actually utilize the memoization technique here, right? Again, I am telling you, this solution is almost very similar to the memoization technique. The only difference is here we are always returning false, but in the memoization technique we might return true also. Memoization solutions can also be called as DP solutions. The only difference is this is the top down approach, where a little bit of a stack is involved, because in the top down, the memoization approach, we do have to call the method recursively, but we actually return from this part of the code, like how we are returning here, and we return the result also. Okay, anyway, let's not waste more time. Okay, let's get into the memoization solution. In the memoization technique, what we can do, we can actually remember until how much index we have already processed and we have a solution. Okay, that's why I am using a Boolean array here. Okay, so Boolean memo array equal to new Boolean, and the size is s dot length. Okay, I'll call this can segment DFS, we'll call it memo. Okay, let's call it memo. Okay, and we'll call this memo, we can call this memo. Instead of visited, now I'll pass memo array. Okay, or a map also we can create. Okay, because we know how many max keys this memo cache can contain, so we can go ahead with this array. But there are certain scenarios where you don't know, you can go ahead with the map. Now instead of set, we'll pass the memo array. In the memoization technique, we just save what we returned, right? So we can save memo start equal to false, and here memo start equal to true. Okay, now we will get rid of this visited set. Memo start. So memo start can be false or true, so whatever it is, right? If memo start not equal to null. We are using a boolean object here, so initially it will be null, and in this method it will be either true or false for every index that we are processing. Okay, so finally here, if memo start not equal to null, then we will return memo start instead of returning false. Okay, fine, and we'll get rid of this substring also here. We'll get rid of this visited also here. Okay, and I think this should be it. Yeah, here we will pass the memo array, right, instead of visited. Yeah, fine. Okay, let's run it. Okay, good, accepted, and now submit it. With the visited set or the memoization technique, it's almost same, and actually it's same. Okay, there is not much difference, okay, at all. Until now we learned DFS, we did further optimization, and we did DFS 2 where we used index and we optimized it further. After that we also used the memoization technique and we solved it. Okay. So until now we have actually done DFS, we did the DFS 2 using index, we got rid of extra substring, okay, and we solved the DFS problem using a visited set first, and then we also used memoization technique and solved this problem. So the next optimization that we will do is using DP, dynamic programming bottom up approach. Okay, so in the DP bottom up approach, what we will do, we will get rid of this recursion completely. The approach that we are taking here, the solutions that we are writing here are nothing but actually we are checking all the substrings, and we are checking if all those substrings all together are actually forming the given string or not, right? Instead of going via this DFS route, simply we can use two for loops, right? Two for loops to find out all the substring and use the memoization technique there, and that's it. So now keeping this in mind, two for loops, finding all substring, use the memoization technique, and let's try to write a DP solution. Okay, all possible substrings, okay, for int I equal to 1, I less than given strings length, so s dot length, or equal to less than equal to I plus plus another for loop which will start from 0, int j equal to 0, j less than I, and then j plus plus. Okay, yeah, and this for loop. Okay, inside this we will use the same substring method, so s dot substring starting from j to I. Okay, and this is substring, right? String temp. Okay, this is the code to find all possible substring of a given string. Even though we are trying to approach the DP solution using these two for loops, right, we are not improving the time complexity. Okay, we are still using the same n cube time complexity. The only difference is we are getting rid of the extra call stack to some extent. Okay, now what will we do? If we see this particular solution, the earlier memoization solution, we were checking if the left part does exist in the dictionary. If it exists, then we return true, right? So what will we do here? If dict dot contains, right, contains what? Temp, right, and what? So here, right here, we actually checking if the substring from j to I exists in the dictionary or not, right? So what is remaining? So the remaining part is 0 to j, right? So we can say 0 to j, right? So we can say that if the first part 0 to j, right, or the string which ends at j and the substring from j to I all together, both together are present, then we can return true, right? So to capture that information, okay, we can take a Boolean array, we'll call it dp, okay, equal to new Boolean, size is s dot length plus 1. Bottom of dp, usually length plus 1 is the size, because we start with an assumption for the first index that it is true or false. That's the base case, you can say, okay. Here dp 0 is true, means till 0th index we have already seen that in our dictionary. And now we can say here dp j equal to true. So if dpj equal to true, which means substring until j is true, then what we can do, we can actually return from here, right? Right here we are not in a recursive call, we'll just break from here, okay, so that the next substring will be processed, okay. So we'll say break, okay, and okay, like this memo start true, okay, we are remembering, we are remembering how much we have processed, right, which index we have processed. Similarly, we will remember here dp I equal to update our dp array equal to true, okay. Why dp I? Because actually if you see this substring, we are finding the substring from 0 to 1, 0 to 2, 0 to 3, like that, okay. So if we have found, if we have seen that in the dictionary, then dp I, right, so till ith index we have found a substring, right, that's what we are updating here, okay, dp I equal to true. And finally we'll say return dp s dot length, okay. It means we have actually processed the entire string and we have found all the substrings in the given dictionary, okay. Let's move this comment to this place, okay. Let's wrap this method, let's call it can segment dp, right. We'll get rid of this memo, okay. We'll get rid of this start index also and close the code segment. Let's just copy this code and test it in lead code. We should put this before actually in the if block, okay, yeah. So that's why it is 30%, now it will improve, so we'll submit. So now we saw that even using the DP solution we could not improve the time complexity, okay. So we in fact did much better in the DFS memoization than the DP solution for lead code at least, right. But yeah, any approach is fine, all of them have O of n cube time complexity and space is O of n, okay. Here also we are using extra space for keeping track of the DP array. Okay, that's it for today guys. I wanted to actually cover the BFS approach to solve this problem also, but I think this video will be too long, so we'll stop here, okay, and continue watching the third episode where you will find the BFS solution, okay, breadth first search solution to solve this problem. Again, in BFS we don't use recursion, okay. Time complexity is not going to change, but that's an advantage. We are not using recursion there, like how we are not using recursion in the DP solution also, okay. So thanks for watching, see you next time. Until then, bye, take care. Thanks for watching, guys, and this is my channel. This is what I'm going to do, guys. I'm not going to do thousands of problems in the lit code in my channel, but I would like to target certain questions which are very helpful to open your thought process for cracking a coding interview. You can encourage me by subscribing or liking my videos. Stay tuned and see you next time. Until then, bye, take care.